Hello, everyone. Hello, hi, good afternoon. So, I'm back again. So, I am welcoming you guys all in this lead code series, or let's say DSA series. Here we try to solve one problem per day. So, let's go and let's not delay it further. So, let's go to a lead code. Yeah, and today we are gonna solve problem on maybe the topic is two pointer, let's say, and we'll pick try to pick only easy kind of problems. Hmm, let's say happy number. It's easy and it's a two pointer concept. So let's see and let's read it. Write an algorithm that determine if, I hope guys it is visible to you. Yeah, so write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process, starting with any positive integer and replace the number by the sum of the squares of its digits. Repeat the process until the number equals 1, where it will stay, and or it loops endlessly in a cycle which doesn't include 1. Those number for which this process ends in 1 are happy. Return true if n is happy number and false it no if not. So yeah, we need to do something like we have 19, right? We have 19 as a number. What we need to do in a loop, the first digit is 9 and the second digit is at tens place is 1. So 1's square of 1 and plus square of 9 is equal to 82, right guys? Then square of 8 plus square of 2 is equal to 68. Square of 6 plus square of 8 is 100. Now square of 1 plus square of 0 plus 0 equals 1. So if any number, let's say this 19 is ending at 1, that means this 19 is happy number. If any number that is not ending with 1, that means that number is false. So guys, let's check. If I have 13 and is equal to 13, so uh, 1 square plus 3 square is 3 square is 9 plus 1, 10. 3 square is 9 and 1 square is 1. 9 plus 1 is 10. So 1 square plus 0 square is equal to 1 square is 1 plus 0 square is 0. That means 1. So ending with 1, that means true. Let's say, let's take another number. N is mm, N is 11. So 1 square plus 1 square, that is 2. And okay. If n is 1, that means ending is 1. True. If n is 2, ending is 2. That means false. If n is 3, ending is ending with 3, that means false. If n is 4, that means ending is 4. That means false. I'm just doing dry run, guys. N is 5. That means ending is 5. That means false. N is 6. That means ending is 6. N is 7. Ending is 7. That means false. And N is 8. Ending is 8. That means false. N is 9. Ending with 9. That means false. N is 10. Ending with 1. True. Hmm. Okay. So if we have left with single digit number, and that is not 1, that means we need to return false. And if we have single digit number and if that is 1, that means we need to return true. So the base case is we need to have the single digit number. Okay, guys, that's it. Now we need to do something else. Just read problem statement once again. Happy number is number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Okay, okay, done. Repeat the process until the number equals 1, where it will stay. Or it loops endlessly in a cycle which doesn't include 1. Okay. Those number for which this process ends 1 and 1 are happy. Okay. So we have defined the base case. What should be the base case, guys? We just have 1 and number. Okay, so let's go and do something. So n is, let's say, 21, while n now n is equal to, firstly check if n is equal 1. If yes, return true. Else, else or just not else. Let's do uh, as it is. Mm, n is equal to, not like this. Actually, we need a loop, guys. to do this thing. So guys, you can see if we are just consoling console.log and 21 divided by 10. So what is the output? Okay, sorry guys. I'm really very sorry. I forgot. Yeah. So you can see 2.1. And if I see math dot floor, so we are getting 2. And if we need last digit, then we'll be doing per modulo operator. I think we'll be getting 1. For last digit, the operation is modulo, yeah, 1. And if we are doing this with 2, only 2, I think we'll be getting 2. 2, yeah. Okay, guys, I think we should wait for a minute. I'll be coming. So, hello guys. I'm very sorry. Actually, someone was waiting for me, so that's why I went there. So yeah, let's continue. So we have n. Okay, n is number. So what we can do? We can take one variable. Let temp is equal to uh 0. Yeah. And now what we can say, temp is equal to temp plus, and uh, we need last digit. For last digit, we need to do n divided by n modulo 10 and last digit of square. Okay. And then what we need to do, n is equal n divided by 10, and for which we can see math dot floor. Okay, by which what we can do, firstly n is 21, so release one will be releasing here, 1 of a square plus equal temp, and then in n will be having 2, n is equal to 2, and then 2 modulo 10, modulo 10 square, so 2 square, so 2 square, and then we 2 divided by 10, that means 0, and in 0, if n is 0, it will not run. And after coming to this while loop, coming out of this while loop, we can say that n is equal to temp, because we are checking here, we are checking here. and this condition is false. We need to check here is n divided by 10, that is math dot floor. Okay, sorry guys, let me just erase it. We need to just check that if that number is math dot floor n divided by 10, and if the number is greater than 0, that means if we are having 0 to 9, that means single digit number, it will give us 0. If the number is 10 and above, that means two digit number. For every number from starting 10 to anything, it will give us more greater than 1, greater than 0, sorry. So here we are checking, and we can put one more condition here, and this number whatever number is num num is equal 1. If it's not, we'll go out of this while loop and return false. Now let's suppose uh, we have right now in the end we have left with the value of 2. So for 2 it will not come, right? It will not match this condition. So it will not come here. Okay. I think what we can do is we can cut this portion out. We can put it here, and we can put this here, and we don't need this condition here. If the value is itself single digit, don't go inside because we have single digit number now. Just check here. If n is equal 1, whatever is, return true, else return false. And if the number is not single digit, just try to convert it into a single digit number. And this logic will converting this logic is for uh, converting n into single digit number. Mm, okay guys, let's just try to code. Yeah, I'm not sure what it will become, but yeah, let's try it. While math dot floor n divided by 10 is greater than 0. That means it's a not a single digit number. Otherwise, check n is equal 1, return true, else return false. And here we can say let temp is equal to 0 while n let's say we have 19 in it. 19 will come. Firstly, temp is equal to temp plus n modulo 10 for a square is this last digit, square of last digit. Then we need to remove that last digit. N is equal to n math dot floor and divided by 10. So here 19 will end. Then after coming out of this inner while loop, we can assign this n is equal to temp because we need that updated value and the updated value is in this temp. Okay guys, and if that value updated value is single digit number, so it will not come inside, it will just check. I think guys I have written the code correctly. Let's just check. Accept it. For 90 expected is true and output is also true. For 2 expected is false and output is also false. Let's okay, sorry guys, let's try to submit it. I am hoping that it will get submitted. Okay, there are 420 test cases out of 416 has passed, but 470th 17th was not, and is equal to 7. Expected is true but it's false. Okay, I think then I am thinking in wrong way guys. I was thinking that if it's a single digit number and if it's not 1, that means we need to return false. 7. 7 will become 49 and 49 will become 4 square plus 9 square. 4 square is 16 plus 9 square is 81. So 7, 617, 819, 97. So now 97 will be like this. 9 square plus 7 square. 9 is 81 plus 7 square is 49. Now 9 1 10 10 0 1 8 for 12 1 8 for 12 or 1 13. Now 13 be like 1 square 3 square plus 0 square, that means 1 plus 3 square 9 plus 0 square 0, that means 10 So one can go true and two can go false. For 7 it is coming true, right? We can say or n equals 7. Try returning true. I think this test case will pass only, but I'm not sure. Okay, accept it. Beats 100%. I was not sure, guys. 0.06. Damn, amazing. So, guys, yeah, for single digit number, for 1 and for 7 only, it will convert into true, otherwise it will become false. So this is the logic, guys. You can see a simple, very simple logic. Firstly, we have seen the try run code here, hold the code, every code, like whatever we have, you know, whatever we were thinking, whatever we have described, and whatever we have understood from the problem. So this is kind of stuffs we have. So yeah, finally we have done with the DSA day of the day, DSA problem of the day. So yeah, guys, and I am really sorry for the timer, this stopwatch. Actually, I forgot to start initially, and then when I came back from a break, it was not a break, but by suddenly I need to uh, go there. That's why this break thing was happened. So yeah, I'm really sorry for the stopwatch, but yeah, for tomorrow's, I'll try my best to, not uh, going to do any mistakes with this stopwatch. So yeah, guys, let's reset it. So we have done this happy number problem. I am very happy, guys, and I hope you have understood something. And uh, as far as I know, I think it will help you guys in some way. Okay, guys. So thank you so much, guys. We'll be meeting soon tomorrow. Uh, if I'll be alive, then definitely I'm going to meet you with another problem of TSA tomorrow. Thank you so much, guys. Take care. Bye bye.